Hi students, welcome back. Today we are going to look at the min stack problem on LeetCode. Let's look at the problem statement first. So the problem statement says we have to design a stack that supports push, pop, top, and retrieving the minimum element in constant time. So we have to support push, pop, top. These are regular stack operations anyway. The additional thing that we have to support is retrieving the minimum element, and we have to do all these in constant time. This is the important part. Okay. So we will be given a minstack class and we have to implement these methods. Void, push, pop, top, and get me. All of them in order of one time complexity. So let's look at how we can do this. Okay. So let's say we are given three elements. Okay. Which is 2, 3, and 1. Okay, let's say we are given 2, 3, and 1. For, we should implement push, pop, top, and min, right? Push, pop, top anyway are regular stack operations and they are in order of 1. So the critical part here is getting the minimum element in the stack. Let's say we are given this element in this order. So when we push it to a stack, this is how they will be. Initially 2. At this point, minimum is still 2. When we are given 3, at this point, minimum is still 2. Now, if we get 1, the minimum becomes 1. So, the idea here is at each point, we have to maintain the minimum. So, how do we maintain the minimum? We can't just do it in a single variable because we have the pop operation as well, which will remove. So, we have to keep a sequence of minimums till this point. For that, we will use another stack. So, what we will do here is initially at this point when you are at 2, what is the minimum element? It is the first element, so the minimum is 2 itself. Now when we are at 3, what is the minimum element? We already have 2 in the minimum stack. This is min stack. Okay, and this is the regular stack that we have. When we are at 3, we have a minimum of 2. So at this point also the minimum is still 2. So we don't have to do anything. Now when we are at 1, what is the new minimum? This one is less than the current minimum we have. So this will be our new minimum. Okay. So what will we do? We will push that new minimum to this stack. So now when someone removes one, okay, we will also remove this one. So we will have the minimum element for the remaining stack. Okay, the simple idea is to maintain minimum at every point in the stack. So let's try and implement this. Okay, so this is the class which is already given to us by LeetCode. So we have to have two stacks, correct? One is the regular stack and the other one is a min stack. Okay, I created two stacks. Now, don't need this. How do we implement push? Let's do a regular push first. So if we just have a stack, push, pop are simple things. Okay. Even in case of pop, we don't have to return. So I just did stack dot peak. So for the top, we have to just look at the element and return that. So DQ has something called peak and we are using that. Now for the min, what we have to do? We have to return it for the min stack and we have to peek the element from the min stack. But in order for this to work, we have to maintain the minimum element. So that means whenever we are pushing, we have to check if the current element is less and then do the push. So we have two conditions. What are those? First of all, if the min stack is empty, which means this is the first element in the stack, or if the current element, which is the val here, is less than or equal to the current top element in the stack, min stack. Okay. So in these two cases, what will we do? We will push the element to the min stack as well. So if we what we are doing, if we find a new minimum, we are pushing it to the stack. Okay. Similarly, when we are popping, if we are popping the minimum element, we have to remove that from the min stack as well. So what will we do? When you are popping the top element, which is stack dot peak. If this is equal to minimum dot peak, that means what is this condition checking for? If the top of this stack is equal to the minimum stack's top, okay, then we are removing the element, which means if we are removing a minimum element from the current stack, which is actually when we are removing one, we have to look if one is the current minimum in the min stack, which is true, then we have to remove it from the min stack as well, because once one is removed, you can never say that one is the minimum element. Okay, so that's it. That should work for us. That's how we can maintain a min stack. Okay, something is okay. We didn't pass the value. Okay, okay. Let's submit this and see. Okay, so the time complexity of all these operations is order of 1. Since we have additional memory, but the actual operation is we are just using peek and pop of stack implementation. Okay, that's all we have for this problem. Hope you enjoyed it. As always, keep practicing. Happy coding. Bye.